Welcome everyone. Welcome to this session, the next one in the line of Windows 8 sessions today and tomorrow. This one is called Unwrapping the Notso-obvious. Let me first say what you can expect of this session. It's actually a bunch of things we noticed while building Windows 8 applications, a bunch of things that aren't so obvious at first, that we thought, by we I mean me and people at my company, that we thought would be nice to share because other people probably run into the same problems we ran into, or in the same, oh, what the hell is going on here, things we ran into. So that's why we created a session like this. So it's actually about 10, I think, tips and tricks and gotchas that we ran into. This is recorded, so I'll have to introduce myself again. Sorry for those of you who were here already. I'm Kevin. I'm a technical consultant at RealDolmen, which is one of the bigger ICT companies in Belgium. I come from a web background, so I've been doing a lot of work in the last 9 years with ASP.NET, web forms, back then still VB.NET, C# gradually. And from that web stack interest, I went to Silverlight. So I did that for a few years actually. So I've done a lot of XAML, and going from Silverlight to Windows Store application development with some WPF and WinPhone in between. That's quite a logical step. A lot of the knowledge you had from building XAML apps can simply be used in building Windows Store apps. So also wrote a few books on that Silverlight development, which are available at Pack Publishing. The easiest way to reach me is undoubtedly Twitter, so you can find me there if you wish. But if you want, you can also send me a mail if you have any questions or requests or whatever. So next to my day job, I have a small job on the side, which I build apps, or we rather build apps. And this is probably the one that's best known. It's actually a Windows 8 client for Facebook with a bit of a twist. Okay, so what can you expect from this session, or rather, what are the topics? We'll talk a little bit about suspension manager and passing complex types, or rather, how that will crash your app and what you can do about it. While we're at it, we'll look into how we can manipulate this navigation stack and show you why you would want to manipulate it in the first place. The third one, it's a bit of a weird one. It's called handling exceptions in awaitable methods that aren't awaited. How do you do that? Because you will see that you will actually just lose your exceptions if you don't really look at this. Then one that's often asked, typically by clients, I want a variable sized grid. So the grid view you see in a lot of Windows Store applications. How do you get that to display some blocks bigger than other ones? Like if you go to the Windows Store, you have big blocks and some small blocks next to that. I'll show you how you can build a grid like that. And while we're building a grid, we might as well look at something else grid view supports, which is incrementally loading data. If you have a data source which has thousands and thousands of records, you obviously don't want to just load them all at once. So how can you do that? And we'll also look into how you can start debugging a background task. It's actually a pretty silly topic, but it got me and a few colleagues. We just couldn't find how we could do that. So we'll talk about that. And then how can you get local host access? That's a requirement that pops up often, especially with bigger businesses and enterprise clients. How can you get that? Can you get that? Should you get that? We'll look into that. And then we'll look into a few tips on async and await. More specifically, how you can cancel a running task and why you should cancel them. And how you can wait for one of a bunch of tasks to be completed or for all of these tasks to be completed. And I have a bunch of performance tips and tricks. So it's actually a big list, mainly XAML tips on how you can improve performance of your application. You always have to remember we as developers, we work on development machines. We have 4, 8, 16, if you're very lucky, gigs of RAM. But, well, your app will probably also run on an ARM device, pretty low level, 2 gigs of RAM. I see most of them on the market. So you can expect about 1/4 of the performance there. So how performance is very important, of course. And end with one tip, which I think is probably the most important one. But I keep that for last. And I hope to leave a bit of room for Q&A afterwards. Let's start with the first one. What is the suspension manager? Why is it crashing when I pass in a complex type when I navigate? I do have to explain a few things about this one first. First of all, what is that suspension manager? A suspension manager is a component that's included in Windows Store applications. And it is typically used to enable you to save state between different times your user starts up your application or terminates it. As you might know, much like Windows Phone development, not completely the same, but much like it, your application doesn't just keep running in the background. So when the user navigates away from your application, after a few seconds, 5 seconds, your application is suspended, which means all running threads stop. And well, your application is actually effectively halted. It's a bit of a memory dump, and it's automatically given back when you navigate back to that application. But once your application is in suspended mode, it can be terminated. Windows can terminate it, and it will terminate it when it needs more memory, for example. You do not have control over that, or at least you can't stop that from happening. And what's even more important, you can't do anything anymore when your app gets terminated. So there's no terminated event or anything. But you are expected that when your user navigates back to your app, that your user just ends up where he left off. So even though your app has been terminated. So that means you need some kind of way to save state. So to save what's on screen when your app gets terminated. That's one of the responsibilities of the suspension manager. And the other one is you'll probably want to save where you are in the application. So if your app gets suspended, no problem. The user goes back, your app is running again, you're just back where you left off. But if your app gets terminated, well, next time the user starts it up again, your app effectively starts up again. So you need to automatically navigate to the page the user was before to give him the impression that the app was still running. So the suspension manager can do that for you as well. It can save the page you were on. And that's where this problem arises. So this suspension manager, built into Windows Store apps, by the way, it's typically very good for the simple apps, but you might notice that after a while, if you're building really complex apps, you might want to have your own component to handle this saving and restoring of state. For most apps, suspension manager will do. And well, then you run into a problem when you navigate to a page by passing in a complex parameter as an argument. So I'm going to show you first that it actually crashes. Let's just run this. It's the same application as before, but a little bit changed. You can already see the bigger sized, variable sized wrap right here. Now, let's see. I need to navigate, passing in a complex parameter. Oh, that's a breakpoint. Where are we? Here we were. Here we go. Sorry for the scrolling. That should be big enough for most of you, I hope. Yeah. If you can't see, shout. So what I do here, when you click the header, I get the data context of that header, which is a catalog category, and I pass it in as a parameter to the product category page. In the product, so this is a complex complex type. It's a catalog category. I'm going to put a breakpoint here, and then on product category page, I'm going to put a breakpoint as well. Product category in the onNavigated2 method, of course. And load state in this case gets automatically executed after you've been navigated, after you have navigated. And here you can see I just get the navigation parameter, of which I know it's a catalog category. Simple enough. There we go. And that works, of course. What happens behind screens, as I'm using the suspension manager to save state. If I terminate my app, something's going to happen and it won't be so nice. So I use suspend and shut down. An error message, the suspension manager failed. Bit of a problem. And if I continue, we even get a nice, I used to get a nice catastrophic failure, but anyway, fact is the app crashes. Why is this? Well, I'm gonna show you the suspension manager built in. So normally you don't even have to go and look at that one. Let's see. I'm gonna go to the right one. Save frame navigation state. This is where the problem happens. Frame.get navigation state, what this tries to do is it tries to get the navigation state logically from your main application's frame. So to enable the back button, etc., your application frame automatically keeps track of where you've been and what you've passed in. And this all works very nicely. You don't have to do anything for it, actually. But the problem is that this statement will try to serialize your navigation state. So it tries to serialize it to string and then save it into in a navigation, in a dictionary named navigation in this case as key. The problem is that this statement fails if you pass in a complex type because it simply doesn't know how to serialize that complex type. And adding the necessary data contracts, etc., or data members doesn't work either. So we're in a bit of a problem here because passing complex parameters and using the suspension manager, that's a mismatch. It won't happen, it won't work. So how can you work around that? Well, there's actually two ways of working around that. The first one, and that's actually the one I prefer, do not pass in complex types. It's as simple as that. Instead of passing in the complete catalog catalog category, just pass in the ID of what you want to navigate to, and then relay the responsibility of getting that item to the view or view model rather you are navigating to. But some people do like to be able to pass in these complex types somehow. So what's the other workaround? Well, you just serialize them yourself before passing them in. So what you do, and I've included a code for that, you can just download it afterwards. Let's have a look again at my products group page. I'm gonna have to put this in comments, so that's what made it crash. And it's the complete same code, and this is what's different. So I have a JSON helper class, which actually just serializes my catalog category to a JSON string. So instead of passing in a complex object, as far as the suspension manager is concerned, I am now passing in a string, a bunch of JSON. So when I navigate, I pass in my complex object as a JSON string. And of course, when I get to the product category page, I will have to deserialize it, which is this statement. Now, of course, this will work. You will be able to pass in complex types, but there are a few things that probably won't work anymore. as far as the compiler is concerned, or your CLR is concerned, rather, this category is no longer the same one as the category you've passed in. It has the same properties, it has the same IDs, but you can't do a dot equals anymore, because as far as the compiler is concerned, it's a different object, it's a different instance. But it's a workaround that kind of works for a lot of people. So that's one way you can solve that. Probably best to show you. Okay, so navigate here, serializing it to JSON first, serializing it back from JSON, and so far so good. And now this shouldn't crash anymore. And there we go. My application was terminated because I pressed suspend and shut down, so it's effectively terminated, but no longer crashes. So that's a bit of a workaround for that problem. Right. But I do prefer the simple approach. Do not pass through complex types. Okay, while we're at it, I'm talking about navigation. Can we actually manipulate this navigation stack? So the navigation stack, by which I mean your application's back button knows where to go back to. That's more or less what I mean by this. Can anyone think of a case where you'd want this? Why would you want to manipulate your navigation stack? Well, an example is showing a disclaimer. So a lot of apps, or well, quite a few apps, have a disclaimer they want to show to your user the first time they use the app. For example, if this app destroys your computer, do not hold us responsible. Something like that. That's the first page that will be shown. So if you do not do anything, your user will go to the main, will go to his first screen. He will accept the disclaimer. He will go to the main screen, and then he will see the back button, and he can go back to the disclaimer. That's not really the best user experience. So to solve this, we can actually manipulate the navigation stack, reset it, so the disclaimer page isn't in there anymore, and the back button won't show anymore. Then there's another thing connected to this. You, of course, only want to show that disclaimer once. So you need to somehow save the fact that your user has already accepted your disclaimer. So that's two things, and I'm going to show you how that's done. First going to have to... No, it should start from scratch if I change this. I'm going to go to my app XAML, because that's where I can define which page is shown first when I navigate, when I start my app. So let's make this a bit bigger for you. And let's see, where are we? Here we go. So this is the, I'm going to show you the onLaunched method. So this is the one that's invoked when your user regularly launches your app. And this is where I state which page should be, the root frame should go to first. Of course, I want to show a disclaimer page now. So let's remove this. And let's do this first. Page is called initial view. Looking for symbol. Might as well have just clicked that one. Yeah, there we go. So, simple view, not much code. And it has an accept button, and for now, all that accept button does is it navigates to my products group page, my start hub. So let's see what gives. Oh, sorry, that's the suspension manager at work. So this proves the previous fix works. It automatically navigates to where I left off. I'm gonna have to do it like this. Uninstall and reinstall my package. Luckily, I only have to do this once. The rest of the demos are without navigation stack manipulation. Okay, wait. Gonna turn this off now. So now I've started from scratch. So now the first page we navigate to is the disclaimer page. There we go. If I accept this, might as well have put the button in gray, but accept this, and we navigate to the main page of my application. Problem, this thing here. I don't really like this. You can now just go back to your disclaimer. That's not really, it's not really a good user experience. So how do I solve this? I solve this by clearing the navigation state once I have accepted. So that's what happens here. I set the navigation state back to 100. That effectively clears it. And I immediately keep a value in the local settings of my app stating that the user has accepted the disclaimer. This means that I can now check in my application startup if the user has already accepted it or not, and not show the disclaimer a second time. So let's see what happens. That's immediately this code, of course. There we go. Bit of exceptions here. So what I do now is, first of all, I check if the user has already accepted the disclaimer. If he hasn't, I navigate to the disclaimer, and else I just go to the products group page. When I am in the disclaimer, I clear the navigation state, so I don't have the back button anymore, and I tell the app that the user has accepted the disclaimer. And of course I navigate. So let's see how that works. Okay, first time, show the disclaimer, that's good. Accept it. And I'm in my main app without the back button here, so the user can't navigate back. And I stop the app, and let's start it again. And there we go, the disclaimer is no longer shown because it has been accepted. So that's one of the reasons you might manipulate a navigation stack and why you would do it. There's other reasons depending on how you design your application. For example, one of the cases might be you have some sort of messaging part in your app, and you use navigation by passing in a parameter showing the user you're talking with or having a conversation with. Typically, if you press the back button, then you do not just want your UI to go to the previous user, you want your UI to go away from the conversation part of your app. You can also use navigation stack for that, or you can just not use navigating for different users. Anyway, lots of ways around lots of problems, as usual. Right, can you handle exceptions in async methods? Well, it sounds a bit logical, and you can, of course. But here's the thing. If you write an awaitable method, so an async method is a method that can be awaited. If you fire that one, and an exception happens in that method, your exception is actually lost. You would expect it to show up in unhandled exception. So some kind of exception happens in a method in your code. You do not catch that exception, so you forgot to try catch. Of course, that never happens, but well, you forgot to try catch, well then you might expect it to end up in app unhandled exception. But no, if you do not await an awaitable method, it's just lost. I'll show you immediately. And you might say, well, okay, the exception is lost, that's good. My code keeps on running, which is indeed a fact. Your code keeps on running. But the thing is, if an exception happens in your code, well, you typically want to log that somehow, or you typically want to know that, because that means something unexpected has happened in your code, and your code might not continue to behave as you want it to behave. So, a bit of a problem. How do you fix that? Well, I'll show you. First, I'm going to show you what's happening, of course. So, let's go. Here we go. I have some demo code. Let's make this a bit bigger. This is an awaitable method that throws an exception. Right, let's go there. If I await this, it will be thrown and it will be shown as well. So let's first do that. By the way, you immediately get in Visual Studio, due to IntelliSense, the message, hey, wait, you're not awaiting this awaitable method. But then again, there are async methods or awaitable methods that aren't awaited. Take, for example, a button click event handler. You could easily imagine a situation where that one needs async code, but you can't just await that because it's a click event handler. Anyway, if I await this, we should see this exception, this one here. And as I'm just throwing it, it should probably end up in unhandled exception. So here we go. And this is where it should end up. Let's try this. That code is, by the way, executed when I start up my application. Just makes it a bit easier to test. So here we go, throw new exception. Let's see. Where am I? Oh wait, no. I need to be... it should actually end up in here. Anyway. Let's see what happens. All right, like this. So I don't await it. That was the thing. Let's run it. So that's what happens. My code just keeps on running. I don't get an exception anymore. I don't see an exception anymore, even though my method has thrown this exception. So that's a bit of a problem. Now, how can you handle this? Let's have a look, because of course there is a trick. There's something called the task scheduler. As you might know, async await, that's actually just keywords and then compiler tricks, which behind screens use parallel tasking. Async, if you ever used async CTP, you probably run into this a lot. You can, by the way, still use task.run here. And this task scheduler has an unobserved task exception event, which you can handle. And exceptions that happen, like the one I've just shown you, that seem to completely disappear because you're not awaiting the async method, do end up in here. So you can simply use this method application-wide to handle tasks, to handle exceptions in async methods that you would otherwise lose. This exception handler service, that's just a little service I wrote, which will show you a nice pop-up box with the exception. So let's try this again. Only thing I changed was this here. So first demo, we saw the exception. Second one, it appeared to be lost because I no longer awaited the method. Third one, and we should get the exception again. So you can now notify your backend of it and handle it accordingly. There we go. Let's go to my app. Here we go. So this is the exception handler service which shows me the pop-up. It says, well, the unobserved exception was thrown. So that's the trick to ensuring you get all your exceptions, and not only the ones that end up in app unhandled exception. Okay. We actually had to, actually it took us a while to figure that one out. Anyway. How do you implement a variable size grid? We've all seen that one. The Windows Store is an example. It's obviously a bit nicer on the eye to make the more important items bigger in your grid views. Luckily, you can quite easily implement this. But you'll have to write your own grid view, more or less. You just have to create your own grid view class, which inherits the built-in grid view. And in that you can override method. And that method is called prepare container for item override. That method gets executed for each item in your grid view. So when you end up in that method, you can set the variable size wrap grid's row span or column span. The variable sized wrap grid, that is the container, the items panel, let's say, for your items. By setting that, you can effectively state, well, this one should span 2 rows, 2 columns, so it's bigger. So let me show you. Yep. I have a grid on the first page, so my application hub, that's the products group page. Let's see. There we go. I'll make it a bit bigger. As you might see, there's quite a lot more in there than what I can show you, so just download the code afterwards. There's data template selectors in there and everything. So, right, this is my grid view. And first thing you might notice, this is no longer the regular grid view. It's one of my own. I named it home grid view. And second thing, let's just keep that one. Where is it? Oh, sorry. No. Second thing is, of course, the implementation. So, my home grid view, which is, as from the previous example you might remember, bound to grouped items view source. So it gets product categories. Let's go to the implementation. And this is the important one. So home grid view, which inherits grid view, and I override one method. And I make this pretty easy on myself. I just created an index property on the product, which contains the index in the list. And all I do is I check the element that's passed into this method. Sorry, the item that's passed into this method, of course. I know it's catalog product, so I can cast it to that, which is what happens here. And I check the index. If the index is 0, so it's the first item, I state, well, set the row span to 2 here. And for all the rest, set the row span to 1. So, what happens then? Let's put a breakpoint here so you can see will end up here for each item. There we go. Oh, that's still the exceptions. We're gonna see the exception pop up, of course. Anyway, so I will continue to end up here for each item. Just come by the first one. I'm gonna put a breakpoint here just to show you that it effectively changes. Here we go. So that's probably the first category. So here we are in the second one. First item will span 2 rows and 2 columns, and all the rest will span 1. I can continue like that, but it's going to be a bit boring to go through all the items here. Right, let's get rid of that method. And as you can see, first item bigger than all the rest. The fact that some of these items are blue and other ones are gray, that's the data template selector at work, by the way. Okay. I am going to put this back into common because otherwise we will continue to see that pop-up. Right, there's a few more things you can do, of course. The variable sized wrap grid, if you want to use that. You can define if items should be laid out horizontally or vertically first and then horizontally. You can define a maximum number of rows or columns on that one. Sometimes it's okay to just let it handle it by himself. So if you don't, it will automatically take up the place that's available. You can say, no, I only want 1 row or 2 rows. And typically you would want to define an item height and width. Okay, now can you incrementally load data? So, of course, in other applications, we have paging. And typically have a grid view with some paging on it, a data grid, let's say, with some paging. As the design guidelines here state that you should use horizontally spanning grids as much as possible, or rather when applicable. We need another way to get paging on that one. Or rather, we need another way to incrementally load this data. And there's an old trick for this. Something we've used a lot in the past. And that's simply overriding, or rather creating a style for your grid view or list view. In this case, anything list view base, which will contain a scroll viewer. And that scroll viewer will have an event, view changed, it's called here, which will fire every time the user scrolls. And if you use that one, you can simply check the offset. If you're almost at the end, you can automatically or manually start firing the loading of the other items. That's something that, if you've ever had to implement something like this in WPF or Silverlight, you will probably have run into this one. However, there's a better way now. And that's called the incremental loading interface. Support incremental loading interface. It's an interface that's included in Windows 8 Store Application SDK. And if your container control, or rather if your items control, a grid view or a list view, supports this interface, you don't have to write any other code anymore. You don't have to handle the view changed event of the scroll view. You don't have to create your own style just to access the necessary events. You just have to make sure that the collection you're binding your grid view to supports the implements the iSupport incremental loading interface. So essentially what we have to do to support incremental loading, nothing on the XAML side, nothing on my grid side. But I do have to make my own collection type which implements that interface. So let's have a look. I've created that one. Maybe I should show you first what we're gonna do. I'm using REST service from Flickr's API. I'm not gonna go over the implementation details here, but I'm just using that REST service on this page to load all pictures tagged tech days, which is very weird. This one is tagged tech days, but these are that's more logical. These are all pictures on Flickr tag days. And, well, obviously that's a lot. So we can just continue and just keep an eye on this one here. So just continue to scroll. Once I reach the end, you will see that it automatically keeps on loading stuff. And I can go on for a while here. So how do we do that? Well, the grid view itself, that's the incremental load view, obviously. Let's see. The grid view itself is bound to photos property. So I have a photos collection. So let's have a look at that one. Here we go. Photos collection is of type Flickr collection with incremental load support. Obviously that's one I had to create myself. So let's look at that one. And as you see, it's a simple observable collection of photo data common. That's, by the way, what I get back from the Flickr API. And the only thing that's different is that it implements the iSupport incremental loading interface. Now, if you go and look at that interface, it's actually not that much work. So it's two things you have to do. It has more items, property getter. And one method, load more items async. Luckily, not too much work. So it's a bit logical. It needs to know whether or not there are more items. And you will obviously have to tell it how it should load the rest of the data. So let's see how you can do that. Back to this one. There we go. So, has more items. Currently, I simply assume, yes, you have more items. So that's a bit of the easy way out. You might want to implement this a bit further in real life. But, well, this is a demo that shows the principle. So, to load more items, let's start by showing you this one, and I'll go over the rest immediately. Get page, this is the method which calls the Flickr API to get the next tag day stacked pictures. Simple REST call using an HTTP client, and it returns a list, in this case as a task, of photo data common. So it's an async method, which means it can be awaited. An async method must then return task or void. So in this case, task. This is the method that's called, so the load more items async method. And then there's probably some things I will have to explain here. Mainly, why this dispatching here. So in essence, all I'm doing is I am starting a new task. So it runs in the background. I do not want this on my UI thread. That's why I'm starting a new task here. In this task, I call the API. I wait for it to return, still in the background. And I get the items in a result parameter. If you do not do it like this, by the way, you will hang your UI. So that's why this is specifically run in the background. Then the problem is, if you run a task in the background, it's not running on the UI thread anymore. And we're adding items to our collection here. And these items are bound to our UI. So I need to tell my code that it needs to dispatch control back to the UI thread, because otherwise your application will most definitely start crashing, because you are manipulating items from your UI, but from a background thread. And that's why there's a bit of code around this using the dispatcher. So the easy way out for this is do not use a task, do not use a dispatcher, simply call this and add the items to the collection. Problem is, if you do that, your UI will hang because it's loading. Workaround, run it in the background and dispatch it back to the UI thread only at the moment you are manipulating the UI items, which means this will nicely keep on running in the background and your user experience will keep being good. Okay, so that's more or less all there is to this. So it's quite a nice way to get incremental loading of your data in your Windows Store application. And by the way, list view also supports this interface. So grid view and list view both have this. Okay. So this one. You're starting to create a background task and you're putting a timer on it. And if you're lucky, after 15 minutes, your task will start and you have a debugger attached and you can start debugging it. This may sound very silly, but I gave this talk once before and one of my colleagues was sitting there. I didn't even know you could do this, so he was actually waiting for the task to start. How do you debug a background task? Well, that's the question. Well, there's a debug location toolbar, but the problem is it's hidden by default. So if you're running Visual Studio for the first time, you won't see this one. So first thing you'll have to do, you'll have to enable it. Simply find it there, view and on debug location. And the nice thing is, once you have that toolbar, you will see your background tasks in that toolbar and you can just immediately start them without having to wait for some kind of trigger. That's the easiest way to debug a background task. I'll just quickly show you. I happen to have a background task, of course. Else I wouldn't be able to show you this. Let's look at that one. Maintenance background task tile update. Probably this one. Right. A bit bigger. So there we go. My background tasks are available here. And like that, you can actually start debugging them without having to wait for your system to trigger them. There we go. Okay. Next one, big question, actually. Can you access your local host from a Windows Store application? No, actually you can't. Well, let me explain that a bit. There's a very good reason for that. A Windows Store app, typical Windows Store app, by the way, is distributed through the Windows Store, logically. This is a piece of your application should to the end user be a piece of software it downloads or is automatically downloaded without him having to install additional software. Now imagine why you would want local host access. If you want local host access, that means that you want your application to talk to services, typically web services, installed on the user's PC. So that will mean your user, your end user, will have to have a web server, so IIS, let's say. We'll have to install that. He will have to install the necessary services, maybe a database, etc., etc., just to be able to run your app. We're actually not supposed to do that. If you build an app, it should be one that's self-contained. So there's a very good reason why there is no local host access from your application, and that's this one. You can, of course, access services that run anywhere else. Then again, there's always a way. Because while you're developing, you will probably want local host access. That's very annoying if you can't have that. The demos I'm doing are running with a service backend on my local host. And by default, all your Windows Store applications actually have access to the local host while you're developing them. Because when you're in Visual Studio, the loopback rules that normally apply for your apps do not apply anymore by default. You can just state in your project properties, that's where this is on by default, that you should be able to access your local host. So use this network loopback rule and allow me to access my local host. So can you access your local host? Well, no, once your app has been published, but yes, as long as you're developing. Of course, there are always ways around that. If you're working in an enterprise environment, you can sideload your application and install everything on each local user's machine, and there are ways around it, but I would really advise against that. Trying to having the end user to install a bunch of stuff on his PC, that's a bit, we're trying to avoid that these days. So, answer to that question, yes and no. Async and await is a very important part of Windows Store applications. You run into them all the time. But there's more to it than just the async and await keywords, of course. And here's a few of the things that you may run into. And I'll show you the code for that as well. I just have to show you, because else I'll run out of time. One good idea is to support cancellation. So why would you want to do that? Why would you want to cancel a task? Well, imagine you have, let's try and find a good example. Imagine you have a user who is you're making a photo application, and you want your user to be able to put filters on those pictures. It's beginning to sound like Instagram. Your user takes a picture, and he's in your application now, and he selects a filter. But all of a sudden he decides, well, I don't want to do this anymore. I want to take another picture, and I want to build another filter on top of that picture and not on the one I'm using now. Well, the rendering of that picture, that's typically done during using a task, so in a different thread. If you do not cancel that task while your user selects another picture, well, it just keeps running in the background. It keeps eating up resources. It makes your application slow. It makes the end user experience slow. So that would be one of the cases where you could say, well, oh, I want to be able to cancel this task when the user selects another picture, for example. Luckily, all these tasks support cancellation, but you'll have to implement it. How do you do that? In your method signature, you should accept cancellation token. In that method, which accepts that cancellation token, you check constantly, actually, if cancellation has been called on that token. So what you have is, you have a method, a task, let's say. You're launching a method as a task. It's running somewhere on your PC. And in that method, you're constantly checking if the token has been, if it has required cancellation. That token was passed in to that method. So you have access to the token from anywhere else in your application. So if my user pushes the button to select another picture or to take another picture, you just call cancel on that token. And because you call cancel on that token, the method which has accepted it as a parameter, by ref of course, will then be able to handle the cancellation. So what you get when you cancel that task, you should throw the operation cancelled exception, which will then allow you to handle it accordingly. Let me quickly show you that one. I'm just going to show you the code. Right. Let's see. Here we go. I've got a bunch of demos in here, so you can just check them out afterwards if you wish. I promise they work. Task examples. Let's go there. So, what I did was, this is a wrapper method, so I'm going to go to the important one. Here we go. I have a task, which is awaited. And in that task, I pass in a cancellation token as a parameter. This is a long-running task, so I simulate it by doing a loop, 1000, with a delay of 1 second. So of course this keeps on running and running. If it is by any chance not cancelled, I just return we're done. But if it has been cancelled, which is this here, this is the checking for cancellation. So what this thing actually says is, if cancellation has been called on my token, throw an exception. That exception that's thrown is the operation cancelled exception. So if that operation cancelled exception has been thrown, I simply return cancelled. So really that's all there is to this. And stuff like this makes your app, specifically if you have an app that the user wants to have active for a while, stuff like this ensures that resources are quickly released and your app doesn't keep on doing unnecessary stuff in the background, simply by supporting cancellation. There's 2 more things on this, and that's, here we go. You sometimes want to wait until all tasks have been completed until you continue with the other code. The thing I've seen way too often is that people just await long-running task, await long-running task, await long-running task. So what happens then is you have just 3 tasks running after each other. And sure, then at the end you can continue your code because you're sure all your tasks have been awaited and you have all your results. But the thing is, you can do this better. You can just say, well, wait for all these tasks to complete, and instead of running after each other, these tasks will simply start at the same time, and you can continue your code when they've all been completed. So your tasks start at the same time, and you do no longer have to just run the one after the other. So this actually speeds up your app. In other cases, you might want to know when any of your tasks have been completed. Well, that's this statement. So I think that the most important thing here is async and await. Those are just keywords, compiler tricks around parallel tasking. So if you ever used that CTP, or if you've ever read up on parallel tasking, you can use all that logic in a Windows Store application. And it really is worth checking out. This is another one of those tricks. So async methods, if you call them from your UI thread, are automatically dispatched back to your UI thread when they return, which is what you would like in most cases, because if you call a button click handler from your UI thread, you would typically expect a method to return something that has an effect on your UI, showing a message, for example. But in some cases, you might not want to get it back to your UI thread. You might not want to marshal it back to your UI thread, because marshalling stuff back to your UI thread that shouldn't be on your UI thread, well, that actually means you are creating an application which might feel slow for the user, because you're doing stuff on his UI thread, which is what he sees and feels, that shouldn't be there. So that's another trick. If you want a method that you await not to be marshaled back to the UI thread, so the code that ends up here afterwards should just keep on running in the background instead of on your UI, you can just configure it like that. The last statement, configure await false, says do not marshal this back to my UI. Okay. Last bunch of performance tricks, and I'm going to be very fast with this one. First of all, it's maybe very obvious, but check performance in release builds. You're laughing, but really, writing to your output window is tremendously slow for your application. I actually made the mistake of not thinking about it, and I just spent more or less half an afternoon cursing at my code before I realized I put in loads and loads of debug statements to write diagnostic information to my output window. Slow down my app tremendously. So if you're checking performance, release builds and built-in performance profile is probably a good idea as well. The async and await tips I've just shown you, they can really improve performance tremendously as well. And this one's an interesting one. Reduce memory consumption. Well, it's obvious. You should reduce memory consumption, but it's even more important here because, as I've told you before, your application gets suspended and afterwards it can get terminated. When does Windows terminate your app? When it needs more memory for other apps, for example, or it needs more CPU cycles for other apps. Thing is, the less memory you use, the less likely it is that your app will get terminated faster. An app that's been terminated has to start up again from the beginning, so that takes a lot longer than just restarting from suspension, because that's immediate. So that's an extra reason to think about memory consumption in these cases. And then XAML parsing, of course. Your UIs are built in XAML. And there's a lot of stuff about this that can go wrong, actually. But there's a few good tricks. First one, do not load resources that aren't necessary. Might seem obvious again. And I tend to put everything in resource dictionaries. Actually, I used to put everything in one huge resource dictionary. Thing is, when your application starts up and you use one resource from that resource dictionary, the complete dictionary gets parsed. That's typically not something you'd want, especially not at application startup. So use resource dictionaries, but do not use resources from your resource dictionary on the first page of your app. And think about how you divide them. So do not put stuff in a resource dictionary that's only used on one page. In that case, put it on that page. So it's only loaded and parsed when the user goes to that page. Optimize element count. This actually means grid with a rectangle in it means that your XAML parser creates 2 objects. The second one means that it will create 1. Very small things, but it can help. Reuse brushes. So if you put your brush in a static resource, you can see their text color. Color of the text box foreground is the same as of the other button. If you put it in a static resource, that is reused. So your XAML parser is smart enough to reuse it. So only 1 instance. If you do not, he has to create 2 brush instances. So again, small things, but they do help. This is not even that small. This really has an impact you can see quite easily. You should minimize redrawing to the same place on the screen. What actually happens here is that a grid is drawn over your full screen, so black completely, and then one row is overdrawn with white. So that means, first of all, your complete screen is drawn in black, and then part of it is overdrawn in white. It's actually better to write it like this, even though the element count is higher in this case. Instead, I think that should be 0, by the way. Instead of drawing your complete grid in one color and then overdrawing part of it, you simply only draw color where it should be. So no extra overdrawing. And there's a lot more performance tips concerning XAML on that link if you wish. Okay, most important one. I think at least. Well, we're all developers here, I think, or most of us. So am I. And there's one thing I learned by building these apps is that there's one thing you really need, and that's a designer. It's not something I can just do. I would love to be able to do this, but it's a job. It's a job in its own. Those are people that they study for years on this, so we can't expect ourselves to just be able to do that, and we shouldn't tell our clients that we can. So that's probably the most important tip here. And with that, if you have any questions, I'd be glad to answer them. If you don't, and you happen to get one later on, just send me a direct message or something. Okay, Thank you.